Okay, welcome back for part 2 of delivering UK Industrial Decarbonisation through CCS clusters. We had a session earlier this morning with 3 speakers. Just looking back at the previous session, it'd be hard not to be encouraged by the previous session. The fact that the Honourable Costain would keep his commitment to join us, speak so positively and knowledgeably about the topic. I think we have a strong voice at the top table. So I'm Bill Spence, and I'll be chairing the session this morning. As I did this morning, just a little reminder of where we've come from to set the scene from where we were in 2015 when we last had a run at deployment. At the time in 2015, there were 2 competing projects. They were what I thought was difficult at the time, but realized in hindsight were quite simple: single source, single pipeline, single reservoir constructs using a relatively proven contract for different structure. The 2 projects were barred from communicating with each other. And at the time, as difficult as I thought it was, when I look at what today's developers are being asked to do, I realized just what a step, what a new dawn this is for CCS. It's no longer 2 competing projects, it's 6 collaborating clusters. It's about a wide range of capture technologies, incorporating a wide range of industries, sharing, commingling CO2 in pipelines and stores. All of this going on without even the comfort of matured compensation mechanisms. And it's no longer just about demonstrating CCS. This is all about laying the foundations for growth, new jobs, reinvigorating regions in clusters. It's a monstrous challenge, and especially for the cluster leads. And we're really privileged to have an impressive lineup. 4 speakers today, do a quick whistle-stop tour around the UK, hearing from each of the cluster leads, their visions and journey thus far with the clusters. I remind you, as a reminder to our delegates, that if you could put your questions into the chat box, they will then get filtered through to us. What we will do is we will hear each of the 4 speakers and then collectively respond to the questions as they come in. So just a reminder to keep the questions coming in. Let me pass now to our first speaker. Our first speaker is Pierre Girard. Pierre is the Director of New Energy for Neptune Energy. His new energy role is tasked with the complementary challenges of extending valuable infrastructure life and scaling up low carbon development opportunities. He's a recognized leader in the development of low carbon energy infrastructure. In his international career, he's held both commercial and technical roles. Today, those skills are used to lead the Dungeness Project. Pierre, I pass the floor to you.
Thank you. Thanks, Bill. Thanks very much for the invitation, and good morning, everyone. So yeah, it's my pleasure to tell you a little bit this morning about the Dungeness project, which essentially is one of the cluster that has met the eligibility criteria as defined by PACE. If we can move to the next slide, please. A little bit about Neptune Energy. I guess we are a leading independent E&P organization with some prior extensive CCF experience and also a big focus on helping with the energy transition and low carbon solutions. Our experience in CCS is a bit unusual. I guess we have 14 years of CO2 injection in the southern North Sea and offshore in the Dutch sector, where essentially CO2 was collected and from the gas that was being produced and then compressed and injected into one of the another gas reservoir. We are progressing in the Dutch sector the Acorn project, which is repurposing of depleted gas reservoirs to turn them into CO2 stores. And as none of, I guess we are partner on Snowbit, so we've some exposure to sort of Equinor's leadership in CO2 storage. And I guess the other main points on that slide on the left-hand side being essentially our experience in terms of offshore facilities operation in the UK and the Dutch sector. And in the UK, just as a reminder, we operate the Cygnus offshore gas facility on behalf of Spirit and Neptune, and that makes a significant contribution to the gas supply of the UK as a whole. And I guess another final point is the subsurface expertise that we bring to the table in terms of the understanding of the potential storms in the area of interest offshore as far as the safe storage is concerned. On the right-hand side of the slide, I guess this is a graphic display of what we are doing in terms of energy transition activities. And so it's not only, as you will see, it's not only linked to carbon storage, but we are also active and taking steps in the generation of hydrogen in an offshore context, and that's a project we have in the Dutch sector, which obviously could have future upscaling opportunities, not only in the Dutch sector but also in the UK sector. And obviously electrification of our facilities as a mean to sort of continue our important contribution to the energy landscape with solutions that are less carbon intensive. So if we go to the next slide, please. So Dungeness, what is it? Essentially, it's a project that a proposal that is focusing on firstly, in the first step, generating significant large volumes of hydrogen, so hydrogen production and CO2 storage volume. So as you see on that slide, I guess one of the key elements of the project that is located in in the southern North Sea area and onshore that is based in the South Humber area. The main element is the repurposing of a number of pipelines. So you will see on that slide of the central point, the landing point or departing point for the CO2, but is what we call the TNEP, which is Thorpe New Energy Park, essentially with the plan to repurpose a part of the old Thorpe site to host a blue hydrogen plant where the gas would be supplied, natural gas would be supplied from the national transmission system. Obviously, there are significant feeder lines existing between the Hatton compressor point and the TNEP point. Obviously, the CO2 will be captured and transported offshore by repurposing the CMS pipeline, which was decommissioned or which ceased to be used about 4 years ago when the field in the CMS area stopped economic production of gas. So this repurposing of pipeline is obviously a main factor in terms of reducing cost and also in terms of minimizing the environmental impact of the undertaking. In terms of targeted stores in the area of interest that is highlighted in red on that slide, you have a number of depleted gas reservoirs as well as four-way deep closures in the Bunter saline aquifer. So it's quite rich in opportunities from that perspective. In the boxes on the right-hand side, essentially you have a phasing of the blue hydrogen plants, and essentially with a first phase of around around 600 megawatts, and then another 2 phases of the same amount. So altogether, adding up to 1.8 gigawatts by 2030. I think an important point on that slide as well is the illustration that this hydrogen essentially would serve not only the Humber area, but also could be sent in the future back towards the grid, in the context of either blending it with natural gas or in the future in terms of having or contributing towards a nitrogen backbone solution. We move to the next slide, please. So high level, we think that Dungeness has the potential to build a world-class large-scale CO2 storage hub, and it's got a very particular and very specific characteristics of being at the crossroads of a number of pipeline, and therefore creating or contributing towards the onshore network of hydrogen, and with potential connection to the South Humber using a new pipeline. The CMA's pipeline capacity can be up to 18 million tons of CO2 per year, so quite a large amount. Not that we would obviously use all of this with blue hydrogen, but obviously that provides scope for accommodating additional emissions, for example, from the South Humber area that could be heading in that direction. We are also looking at sort of shipping solution to increase the capacity of the system, and the specificity of the shipping solution we've been considering is essentially offshore offloading. So as opposed to have your vessels and CO2 cargoes essentially landing the CO2 in a harbor and then using pipeline. Essentially, we are talking about direct offshore offloading of the CO2 load, and for then safe injection and storage into reservoir. Last but not least, I guess there's significant expansion for volume and also for contingency as a result of the diversity and the size of the stores that have been identified in the area of interest. We go to the next slide, please. I guess we see that Dungeness would directly contribute to the 10-point plan. In particular around the sort of low carbon hydrogen targets of 5 gigawatts by 2030, and obviously also in terms of CCUS to decarbonize the UK economy. The Senorthorpe New Energy Park, we envision that as being a place to showcase a new energy solution, and also a way to revitalize the Senorthorpe site. And obviously, Humber is a critical cluster area, or it's a critical industrial area for the UK, but will also become a leading sort of decarbonized industrial cluster, which is a great prize and also a fantastic opportunity to showcase the decarbonization and all the associated technologies that go along with it. We can sort of see, although the numbers need to be refined, but clearly Dungeness will safeguard jobs in the energy-intensive industries, as well as assist the transition towards a cleaner and different energy solution like hydrogen, for example. If we move to the next slide, please. So that's my last slide. Essentially, if we try to summarize Dungeness in one slide, I would say that it's enabling the accelerated and low-cost fuel switching at scale. So, our plan is clearly to produce large-scale blue hydrogen, and also using technology and partners who have long experience in doing so. And with that experience comes knowledge and also efficiency in terms of cost and schedule, etc. And we have identified an area with significant storage capacity at low cost as a result of repurposing of assets. And along with low cost comes a low environmental impact that is associated with minimizing the amount of new pipelines being built. We believe that it is highly deliverable and highly feasible, and all the elements that we are considering, so the blue hydrogen plan, the power island, the transportation and storage, are essentially activities that have been undertaken before by the participants. And also it presents some optionality for the future in terms of shipping solution, in terms of participating and contributing towards the development of the hydrogen network in the Humber area, and potentially also in the future, green hydrogen could sort of be grafted onto the solution, and contribute or provide towards the transition from blue to green in due course. And that's really going to be facilitated by the fact that there are nearby offshore wind farms that could be of easy access. So that's me with some stop tour of Dungeness. So thank you.
Pierre, thank you for that. Really enjoyed that, and a lot of highlights in there. I was captivated by the reuse of infrastructure, the shipping option, but the one that really caught my attention was this idea of bringing in the expertise and knowledge that you have from elsewhere in the world, the Netherlands, Norway. Any chance we can get to stand on the shoulders of those who went before us internationally is a real benefit to us here in the UK. So I found that a really encouraging part. Unfortunately, Pierre won't be able to join us for the question session, but we can post him some difficult ones in the aftermath. So thank you, Pierre.
Thanks again. Thank you.
Just a reminder to our delegates that do put your questions into the Hoover platform, and they will find their way to us for answering at the end. Our second speaker is Alan James. Alan will be known to many of you from his days at his founding of CO2 Deep Store, founding of Pale Blue Dot, and most recently as Chief Technology Officer at Storegga. Storegga is the lead developer of the Acorn project, which is the foundation of this Scottish cluster. Alan, welcome, and I pass the floor to you.
Alan, you're on mute, I'm afraid.
There we go.
There we go. Thank you.
Okay, thank you very much, Bill. Thank you, Pierre. If we could move to the next slide. So my task today is to introduce and talk a little bit about the Scottish cluster and how that's shaping up. And one thing that is apparent in the discussion of clusters is how very different and unique every cluster is. Each has its unique attributes and positive components, advantages and challenges. And it's fascinating to see all of these clusters kind of side by side, each addressing its own needs. So if we go to the next slide, I think one of the factors of the Scottish cluster compared to some of the other industrial clusters is the huge area that we have to cover, from St Fergus in the northeast of Scotland to the Central Belt, Grangemouth, and beyond that into England and internationally. from the very start, the transport and storage system for the Scottish cluster, which we're calling Acorn, has been designed to provide service to multiple emitters. So right from the start, we have envisaged having multiple pipelines, several injection sites and storage sites, and shipping to support remote areas and remote emitters from the start. And we can do that because we're focused on infrastructure reuse. And for infrastructure, we mean really two things. One is the pipeline infrastructure that we have offshore in the northeast of Scotland. And the other one is the deep water port infrastructure at Peterhead. Also, we've been striving to eliminate a single point of failure risk, such that the system can provide robust and resilient service to customers, as well as being scalable up to the full capacity of the installed pipeline infrastructure, which is in excess of 20 million tonnes a year. As far as storage site goes, we're quite lucky here in that 30% of the UK storage resource lies within 50 kilometres of that pipeline corridor that runs offshore. And our first licence area covers both depleted gas fields and saline aquifer storage resource in the lower Cretaceous sandstones. So we'll be starting, as Bill said earlier, standing on the shoulders and the work of others that have come before us by injecting into the Goldeneye depleted gas field, where a significant amount of work has already been done in previous procurement processes to mature that offering as a starting point. So those reservoirs sit around 2 kilometres below the seabed in about 100 metres of water. The difference this time is that it will be done from using a subsea development without a platform. Pipelines represent a major use of capital for CCS projects with offshore storage. And we're lucky enough to have 3 pipelines here, which have very low operational use. And Goldeneye will be the first one to be deployed. And we just completed Intelligent Pig Run with the objective of confirming its suitability for use. That completed recently. As far as emitters are concerned, we have a portfolio of emitters that will be connected to the system. There's the St Fergus gas terminal itself, where there'll be a new capture plant capturing flue gas from the terminal as an industrial source. Just to the south, there's Peterhead Power Station, which will have new post-combustion system installed. Down in the central belt, there is INEOS and Petro-INEOS facility for petrochemicals and the chemical industry sector in Grangemouth. And collectively, those are the biggest emitters in Scotland. So that's very important. Elsewhere up towards Peterhead, we have, and around St Fergus, we have the Acorn hydrogen plant, which will start off with a 200 megawatt plant, with then adding 300 megawatt increments using ATR technology, and a direct air capture plant as well. Once the infrastructure is there, cost-effective transport and storage attracts in other industry interest, and one of those is direct air capture. And it's not an emitter. It's important to remember that it's not an emitter, it's simply a point source, which will be capturing emissions from large British airlines, financial sectors operating in the UK and elsewhere, and removing their emissions from the atmosphere such that they can be routed down the transport and storage system. So further afield, the CO2 supply into Peterhead Port via shipping will come from power plants in Teesside called Crossbill, which will deploy net power technology. And also this week, there have been announced plans to move CO2 from the Isle of Grain Cavendish hydrogen project in the Thames area up to Acorn. And these are augmented by international volumes from Europe, which is not part of the Bayes cluster sequencing process, but a very important step indeed. So shipping supports the scalability, but also supports the resilience. So lots of diversity amongst the CO2 storage, again, important for robustness. We go to the next slide. So by 2030, the kind of base case that we're carrying delivers around 60% of UK government targets for CCS. And that includes a strong contribution towards the hydrogen targets of 1.3 gigawatts, low carbon hydrogen. We'll also be supporting remote emitters around the UK so that plants that perhaps don't have immediate access to local transport and storage can start to decarbonise and are not left behind. And we can also physically offset emissions from the likes of really difficult to decarbonise sectors such as the aviation industry, financial services and the like. And a good plan needs strong delivery, and the cluster sequencing process has brought together a tremendous group of large corporate players, investors with significant balance sheets to deliver the program, which we're very, very encouraged by. And you can see in the pie chart at the bottom there that as a package, the base plan, around a third of it services power by the time you get to 2029. A third of it is industrial support, and a third of it is hydrogen support. You can go to the next slide. So this is the timeline. Again, in deterministic timeline, investment decision at the back end of 22, early 23. Initial volumes coming out of plant in 25 with full commercial operations in 26. By the time we get to the end of 2027, we'll be running at 5 million tonnes a year and approaching the full capacity throughput of the first pipeline, and we'll bring in the second pipeline on stream shortly after that. So that one of the benefits is being able to build this out as the customer demand develops so that it can minimize the risk of any stranded asset here. So by the time we get to 2030, the system should have put 25 million tonnes of CO2 in the ground. And if you extrapolate out to 2050, it could be well in excess of 0.5 gigaton, all in all. Go to the next slide. So this is just a kind of a cartoon section. If you can press the button again, we should get a red box around the offshore part. So you can see the 3 transport systems through the different pipelines. All of the development will be subsea with subsea wellheads and new wells, but using the existing pipeline infrastructure. You can press the button again. Then we're looking at, this is the St. Fergus component. So you see the St. Fergus gas terminal at the back, together with the hydrogen plant, the aggregation system for dispatch offshore. You can also see there at the beachfront. And if you can press the button again, and just south at Peterhead, around 10 kilometers south, this is where the deep water port is for the arrival of CO2. We've also got the SSC power plant here, and the DAC plant will be located in this area. And finally, one more button press is the Grangemouth plant, INEOS, Petro INEOS and others. That will be connected to the system using one of the gas feeder lines that runs from St. Fergus to the central belt. So all in all, you can see how this kind of component starts to build and assemble. And international volumes we're expecting to arrive by ship from 2026 onwards. We can go to the next slide. So as with all of these clusters, they generate new jobs in the low carbon sector, and the Scottish cluster is no different. Our estimates from work that we've done suggest that the cluster, as the deterministic case, will produce about 15,000 new jobs, and really focused on providing a pathway for workers in the oil and gas sector to move into the new low carbon areas. It has mobilized the institutions in Scotland and around skills development and transfer, supply chain development programs, and economic assessment indicates that the program will add maybe 1.4 billion a year on average between now and 2050, and that benefit will be across the UK as a whole. One of the things we're really excited about with the international aspect here is the potential for the system to improve balance of trade by importing CO2 from our European neighbours, and supporting the Northern Lights project in servicing big chunks of the demand for carbon abatement from Northern Europe. So we can go on to the next slide. So just winding this up now, I think the system provides this access to a huge amount of storage resource in this pipeline corridor, which is going to be very important, strategically important for the UK to deploy going forwards. Makes a very solid contribution to the job creation with operational dates early on in 25-26. And the existing infrastructure allows kind of cost effectiveness and resilience as well, together with the use of shipping to enable decarbonisation of regions that don't have transport and storage available to them locally. And finally, if you go on to the last slide, I think I'd just like to thank our partners in Acorn, Humber Energy and Shell, together with the support we've had from UK, Scottish and European government support, our primary emitters, and all the members of the Scottish cluster who've supported who've been helping to support the project get to where it is at the moment. Bill, thank you.
Alan, thank you for that. Again, a really powerful presentation about all the pieces you've got to keep aligned and in touch with in order for this to happen. And I think that the piece, we heard from one of the speakers this morning about never been done before. This has never been done before. And well, that's exciting. It does make everyone, or it makes me a little bit nervous. So I found it really, really heartening to hear about the resilience that you bring with your project, and especially these days when we're a number of shortages that going on, this concept of resilience is going to be really powerful, and I think that's going to be a really powerful thing that you bring to the overall cluster group about how to build that resilience. So thank you for that. I'm now going to take us on to our third speaker. The third speaker is David Richardson. Excuse me. David is a seasoned project specialist with Costain. He's driving the ambition of the South Wales Industrial Cluster and leading the creation of a supercluster program for hydrogen and CCUS development. Dave has the rather unique challenge of having many CO2 sources, but no sinks within his cluster. So Dave, I'm going to pass the floor to you.
Thanks, Bill. Reminder to myself to turn off the mute. But anyway, good morning, everyone, and thanks to the other speakers, and thanks, Bill, for the introduction. So, yeah, I'm Dave Richardson. I'll take you through the South Wales Industrial Cluster, tell you a little bit about where we came from, where we are and where we're going to, and hopefully you'll find it interesting. Next slide, please. So the South Wales Industrial Cluster is recognised as the second largest industrial cluster. It has the largest industrial CO2 emissions of 10 million tonnes per annum, and also 6 million tonnes per annum that are emitted from power generation. The South Wales Industrial Cluster itself contains strategic UK industries, as I'm sure many people are aware of. We have the largest steelworks in the UK, we have cement works, we have oil refining, and we have the UK's only nickel refinery. We also have chemical works, some general manufacturing, biomass power generation, and Europe's largest and the UK's most efficient combined cycle gas turbine power station. So a lot of our manufacturing and products that come out of South Wales actually drive the decarbonisation of UK infrastructure and are very important. So reducing emissions in this region will help the manufacturers to produce low carbon products, which will have a wider benefit across not just Wales, but also across the UK and beyond. The region has a huge offshore wind potential and a huge tidal capability, one of the biggest tidal ranges around the UK. It can also import up to 30% of the UK's natural gas requirements through the LNG terminals, and therefore has the opportunity to produce not just blue hydrogen, but green hydrogen in significant quantities. And that production has capability for distribution across the southwest of the UK and beyond. Like all industry south of Liverpool, and in common with much of the country, South Wales doesn't have a local geological storage capability for CO2. And you've heard from many other speakers about their reusing existing infrastructure, etc. We don't have that opportunity for geological storage. So CO2 shipping is a prerequisite for decarbonisation for us, but also CO2 usage, and I'll tell you a little bit more about that shortly. SWIC recognised that it didn't constitute an eligible Track 1 cluster in the cluster sequencing competition that's ongoing at the moment, which I see as more of a CO2 store sequencing than a cluster sequencing, because it's really focusing on the geological storage. However, SWIC is fully committed to decarbonisation, and we do understand the importance of collaboration across the UK and beyond. And we're keen to ensure that the solutions that we deploy create opportunity for the whole of the UK and aids decarbonisation of the south of the UK in particular. Confidence in CCS has been built significantly in the last 2 years, to the point where multinational companies are now committing significant resources, as you've heard from many speakers. New strategic alliances have been formed in each of the industrial clusters to generate previously unheard of cross-sector collaboration, and I think it's a very exciting time for the industry. SWIC in itself is testament to the ambition of the participants and determination of businesses and true collaboration in what is a diverse and complex industrial region. The maturity advanced significantly from its formation in early 2019. We've raised the region's profile and attracted investment at scale many skeptics would have not envisaged at the start of the IDC programme. South Wales has ambition to be the first cluster with an operational CCS project without direct access to a store, thereby laying the ground for other non-store locations and demonstrating how decarbonisation can be achieved as an example to other regions and the global marketplace. Next slide, please. So, as I said, we're a complex cluster. We have 2 projects in the cluster. We have the cluster plan and the deployment project, similar to all the other clusters. Our cluster plan has 36 partners and is led by CR+. The deployment project has 17 partners and is led by my company, Costain. The output of the cluster plan will be a plan for the South Wales industrial cluster industries to get to net zero by 2040. But I'll take you through in a little bit more detail over the next few slides about the deployment project and what our ambition is there and what our current status is. So next slide, please. So the South Wales Industrial Cluster Deployment Project is quite complex. 17 partners, lots of cross-industry connectivity. It was launched in March this year, having successfully applied for the IDC funds, and builds on the phase 1 work that we had by growing the number of partners significantly from 4 to 17. But some of these partners are also involved in the cluster plan, and we think that's important. The breadth of the deployment project includes decarbonisation of an entire energy chain into manufactured products and fuels, enabling wider use of these in the UK infrastructure of the future. As lead partner for the cluster, we are leading the phase 1 activity, and we pulled together the partners to make a successful phase 2 submission, a challenge in itself. But the project aims to create and contribute to regional growth in one of the UK's key industrial heartlands. We seek to preserve and secure circa 100,000 jobs in Wales-based industries, seeking to create another 5,000 jobs in new skills and new high-value opportunities for the young people of our next generation coming along. And one of our key links in our cluster is the work we're doing with the University of South Wales and how we're involving them in not just the present work, but the future work. We see that the cluster itself could lead to a deployment project with a value of over 2 billion, maybe as high as 4 billion. We're not there yet to say exactly what, but we're exploring that. And that will bring inward investment across Wales, which will achieve the net zero ambitions. The deployment project is formed of several interrelated sub-projects, and each sub-project is undergoing pre-feed and transition into feed as part of the overall project for the deployment phase. The pre-feed work will develop the full chain requirements and business case and identify interfaces, hydrogen demand, and routes to market will be investigated to confirm scale of production, economics, and the basis for feed moving forward. It will also be a period of engagement to seek opportunities and synergies across the South Wales region for hydrogen supply and CO2 export, and to develop commercial agreements for such. Wherever possible, our cluster plan is focusing on reusing existing infrastructure. We have a number of existing pipelines in the region, and of course we have several deep water ports. Next slide, please. So in a bit more detail, we're currently engaged on engineering studies. Those engineering studies are looking at the opportunity for mass blue hydrogen production from natural gas feedstock, LNG, and with CO2 captured for storage. Carbon capture technologies along the South Wales coast, CO2 transportation, shipping, solar energy and green hydrogen and ammonia production form part of our cluster also. Large industrial decarbonisation through fuel switching and process efficiencies, and cleaner electricity production through the use of blended blue hydrogen and the production of cleaner transportation fuels, including sustainable aviation fuel, make up the summary of our cluster. The sub-projects are geographically spread across the South Wales region, from Newport to Milford Haven, a region of about 150 kilometres. They are, however, interconnected through transportation of both hydrogen and CO2 as part of the sub-project activities. Taking you through some of the sub-projects and starting in the west at Milford Haven, we are exploring the production of blue hydrogen at scale using LNG as a feedstock, the CO2 being captured and loaded onto vessels in the port of Milford Haven for shipping to storage sites around the UK. The port infrastructure of Milford Haven is already a significant feature of the UK's energy supply market, with the capacity to unload the world's largest LNG carriers. We are also exploring the opportunity to use hydrogen as a fuel to decarbonise the power plant at Pembroke. Options will also be considered to reduce emissions at the oil refinery run by Valero, aligned to their business ambitions. Green hydrogen and green ammonia are being considered with Lightsource BP. Using solar as an energy source, we will see these new fuels of the future being generated in the region, with also then the potential for the use factor in the shipping themselves using the green ammonia. In the east, we are developing solutions to capture CO2 from emissions at the Uskmouth Power Station. This is a former coal-fired power plant, currently under conversion to bioenergy. But we're also looking at CO2 utilisation at that site also. With RWE, we are considering a hydrogen hub. That hydrogen hub will be run on renewable electricity and therefore will be green hydrogen. Green hydrogen potentially injected into the gas network for use in the region. More centrally, we are developing with Tarmac at their Aberthorpe cement plant strategic option to reduce emissions through use of alternative raw materials and potential fuel switching. At the Tata Steel Port Talbot facility, we are considering how to reduce emissions and integrate infrastructure into other sub-projects, including CO2 shipping, etc. And creating also there an alcohol to jet facility that will consume emissions from the steelwork, some of the emissions, to provide a sustainable aviation fuel, thus decarbonising the challenging area of aviation and providing a use for emissions in the region beyond the capture and storage. The region's gas networks are operated by Wales and West Utilities, and with them we are exploring how the network can be decarbonised, linking the profile of hydrogen production with the potential future users of hydrogen, and considering the opportunity the networks have to support the overall project. Similarly, we are developing the infrastructure needs for CO2 export, considering scale, capacity, location of the source of CO2, and logistics for vessel loading of liquid CO2. Shipping CO2 is vitally important for South Wales and vitally important for the UK. Next slide, please. So this is my final slide. And just to reiterate, our vision is to initiate a robust project for the deployment phase, exploiting the use of hydrogen and carbon dioxide alongside existing regional characteristics, creating new industry whilst protecting existing employment. At phase 2 conclusion, we will be in a position supported by the cluster plan output. So I've produced a firm programme for decarbonisation of a significant amount of current emissions from the South Wales industrial region and its power emitters, backed by a comprehensive infrastructure scheme for low carbon fuels, hydrogen and ammonia production, CO2 transportation and shipping. We will have appraised numerous feasibility options, selected the most economic, fully defined the scopes for each partner project such that a congruous SWIP project can support investment decisions to advance projects towards construction. Our objective focuses on reducing industrial emissions and producing hydrogen at scale and creating new industry for carbon use. We see that is vitally important. So thank you very much for your time. Bill, over to yourself.
David, thank you for an excellent summary of South Wales. Can't help but be impressed with the pace at which your cluster is developing. The maturity is really impressive. And
thank you.
What we see is you have no choice but to ship. And as they say, necessity is the mother of invention. So I think we're going to be looking to your cluster to really be doing a lot of the pioneering work to get shipping up and running. So we look forward to that. Thank you. Very good presentation. We'll now take us to our final speaker. Just a reminder before we go to the introduction of David Parkin, just to keep the questions coming in. We've got a number of good questions there ready to go. But our final speaker, David Parkin. David is the Director of Progressive Energy. He's a recognized leader in the development of low carbon energy infrastructure. Like his peers on the panel, he has both technical and commercial skills. While his career led him into the aerospace industry, I can assure you today his feet are firmly on the ground as project director of the HyNet Northwest project. Dave, I pass the floor to you.
Fabulous. Thank you very much, Bill. Welcome, everybody. So here I am last, but certainly not least, one hopes. So I'm going to talk to you for about the next 10 to 15 minutes about HyNet. So at a personal level, I guess I've been leading in HyNet in various guises for about 5 years. So there isn't much I don't know about the project. And it really is fascinating to look back at where we've come from over the last 5 years. I mean, 5 years ago, HyNet was a twinkle in the eye amongst a few people about how you do large-scale, low-carbon, low-cost hydrogen to make a regional transformation. And on the back of that vision, we are now probably one of the UK's leading low-carbon infrastructure projects, decarbonising a wide range of industrial sectors and providing the infrastructure backbone to decarbonise other hard-to-reach sectors alongside industries such as flexible power generation and heat and transport. So if you go on to the next slide, please. So this is HyNet. So just to get everyone oriented on their geography, this is one of these challenges where I'm going to point vigorously at the screen and no one can see what I'm pointing at. Sorry, if you can just go back one. Great, thank you. So we have Liverpool and Manchester. So we're looking around the Mersey and the Dee here. So as I said, HyNet really is quite an interesting cluster because CCS is the means, but not the end. The end game of what we're trying to do here is low carbon hydrogen at scale, and CCS provides a significant enabler to that. So I'm going to talk about the hydrogen side of the equation first, and then I'll come on and talk about the CCS side of the equation. So on the south bank of the Mersey, there's a big sort of industrial corridor situated between Ellesmere Port and Runcorn, and that is the heart of HyNet land, if you will. And what I should say actually is we're here in the Northwest not by accident. We're here for a number of very compelling reasons. So one is it's the UK's largest manufacturing sector. So there's 350,000 people employed in manufacturing in the Northwest, a lot of heavy industry, a lot of manufacturing industries. Secondly, we have fabulous offshore CO2 storage geology. So I'm going to come on and talk about that, but we're very blessed with good storage facilities. And we also have onshore salt cavern storage for hydrogen, which makes the whole hydrogen system piece work. So you put together those sort of happy accidents of geology and geography alongside the industrial base, alongside the population density as well, which makes it a good target for domestic conversion to hydrogen in the future, and you have a compelling location for a project. So what we are going to do is progressively build out low carbon hydrogen production based at the Stanlow refinery. So Stanlow refinery, owned and operated by SR, Progressive Energy, who I work for. We're forming a joint venture with SR to construct the first 2 hydrogen production plants. Ultimately, we see 4 being constructed there, and all our demand modelling and all of our system architecture is based on 4 plants being built. So the first of those hydrogen production plants has completed FEED. Planning permission has been submitted. We think that makes it the sort of the leading hydrogen production project in the country. So we're very proud of what we've achieved there. And much of that first hydrogen plant, the use of that hydrogen will be on the refinery, and that is for fuel switching to allow them to decarbonise refinery operations. But we will also supply hydrogen to a couple of quite local industries. But then beyond that, we need to build out a hydrogen network. And our partners, Cadent, they are now mobilised on their FEED engineering and consenting of an 80-kilometre pipeline network. So this is, for those of you familiar with the gas distribution network, this is the equivalent of local transmission system sort of architecture. So 40 to 50 bar, up to about 24-inch pipeline. So this is a sizable asset, and it's going to run roughly east up towards Manchester, sort of up towards the Trafford region. And it's going to pick up all the major CCGTs, the power stations along that corridor, and the major industrial users. It's going to run north up into Liverpool City region, into St Helens. And really importantly, it's going to run south down to Cheshire, where we are going to connect to underground storage facilities. So the underground storage facilities are being developed for us by Innovin, part of the INEOS group. Many of you will know that they already operate a significant number of natural gas storage facilities there. They already have planning consent to expand those. what we're doing at the moment, what Innovin are doing, is converting the consents which they have for natural gas storage to hydrogen storage, and they're doing the feed engineering, and Costain and David Richardson's team, who spoke to us previously, are supporting the feed engineering on that package. So I'll talk a little bit later about some of the fuel switching trials we've been doing and some of our customers for hydrogen, but whilst we're still on this graphic, I'm going to talk about the CCS side of the equation. And for this, I start sort of offshore and work in. So out in Liverpool Bay, E&I, our offshore transport and storage partners, own and operate 3 gas producing reservoirs. They're very nearly depleted, but the infrastructure associated with those is very, very good and can be repurposed. So we're reusing reservoirs, well infrastructure, wellhead platforms, pipelines. And those pipelines run ashore in North Wales at a place called Point of Ayr. The pipeline runs along the North Wales coast to a place in Flintshire called Connors Quay, where there's a power station. At that point, we need to put in a new pipeline from Connors Quay to the Ellesmere Port region. That new section of pipeline is a critical path for the whole project. It's about 30 kilometres. It requires a development consent order. We're well on the way to securing that, and I'll talk about that a little bit later. But what we're also doing, as well as picking up the carbon dioxide emissions from hydrogen production, we are picking up carbon dioxide emissions from a number of other major process emitters. So we have the catalytic cracker at the refinery from SR. It's about just under 1 million tonnes a year. That's a major source of process emissions. You can't fuel switch that away. Similarly, just down the road, a major fertiliser plant, CF Fertilisers. In North Wales, we have the Padeswood cement plant. So this will be the UK's first low carbon, zero carbon, and potentially negative carbon cement plant. We also recently announced Girard joining the project. They have the UK's largest energy from waste plant in Runcorn. That's 1 million tonnes a year. So overall, we've got a number of process emitters alongside our hydrogen production facility, which will more than fill the 10 million capacity, 10 million tonnes a year system capacity we have in our CO2 network. So if we go on to the next slide, please. So who are we? Well, one of the things which we're really proud of on HyNet is we are demand driven as a project. So on the left, you see our sort of key CCS partners and infrastructure providers. So Progressive Energy, we sit in the middle and glue it all together. E&I are the transport and storage partners and will own and operate all of the transport and storage network. Cadent on the hydrogen side, University of Chester, our academic partners, Innovin, our hydrogen storage, and then our main CO2 process emitters, CF, Hansen, SR, and Viridor. But alongside that, we have 25 other major industrials in the Northwest who have now all signed MOUs to offtake hydrogen from the hydrogen production facility. Now, this represents 25 terawatt hours of demand. So to put that in context, the whole of the Northwest region natural gas use today is just over 60 terawatt hours. So about 40% of current natural gas use in the Northwest is represented by these industrials, all of whom are looking to take hydrogen from HyNet, all of whom have HyNet front and centre for their decarbonisation plans. Okay, next slide, please. So what do we deliver against the 10-point plan? So the hydrogen production target in the 10-point plan is for 1 gigawatt by 2025. It's 5 gigawatts by 2030. Our rollout plan delivers 4 gigawatts of hydrogen production, but it's not just 4 gigawatts of hydrogen production, it's a pipeline which can deliver that, and it's storage of 1.3 terawatt hours a year, which can manage the supply and demand fluctuations for that level. So the 25 major industrials contribute about 25 terawatt hours of demand. You add network blending to that into the gas distribution network, that gives you about another 3 to 4 terawatt hours, and that takes it up to the 30 terawatt hours, which we're aiming at. We've also undertaken this summer some large-scale industrial fuel switching trials with some of our customers. So principally Pilkington Glass and St Helens, fabulous trial. We have demonstrated that the conversion of a major industrial facility like Pilkington Glass, yes, there's some complexities around safety cases and the provision of hydrogen, but the actual plumbing in of hydrogen into that facility was relatively straightforward, no impact on product quality, Really good trial, and really paves the way for fuel switching across the region. We're doing something similar with Unilever in the early part of next year. We're also providing the infrastructure for HyNet homes. So in December, Cadent will be putting a submission into Bays to build the first hydrogen village in town. That will be built on the back of HyNet infrastructure. So HyNet fundamentally underpins large-scale hydrogen system transformation in the Northwest. In terms of CCS capacity, the UK target is 10 million tonnes by 2030. We have more than 10 million tonnes a year of demand intent. So we are system limited on 10 million tonnes, so we've got more than 100% cover, if you will. It's one of our selling points, if we want to put it like that, to government, that we are confident, we're very confident that we will fill our pipeline. This will not be a stranded asset. There is more than enough demand in the region to fill our system. But what we do to get to that point is a progressive no regrets expansion. We start at 2 million tonnes, we get to 4.5, we move into dense phase, and away we go. Next slide, please. So where are we? So I've covered some of these points, so I'll rattle through because we want to get on to questions, but we're fully funded through to FID. So 72 million pounds of funding was announced earlier this year, so 33 from UKRI, 39 million from the private sector, and that comes on top of the feed funding which we've already received and spent on the hydrogen production plant. Our hydrogen production plant, we're very proud of where we've got to on that. So completed feed into planning, we've submitted our hazardous substance consent, our environmental permit for that. So that's sort of well on the way to being fully permitted as well as feed complete. We have secured our CO2 storage license, or ENI have done that about a year or so ago. The works to secure a permit are well advanced. Conversations with the Oil and Gas Authority are progressing well. The carbon dioxide pipeline, as we said previously, that requires a development consent order. We've completed the non-statutory public consultation on that, and we're right now down into the ecology surveys along the full pipeline routing, engagement with 200 landowners. We are into ground investigations, so we've got drill rigs out on the pipeline, sort of doing boreholes. So, right into the detailed engineering and engagement on that. The hydrogen salt cavern storage, we're well underway on the variation to the existing consent, and that's well on track. And I've covered the last 2 points on that slide, so if we just go on to the next one. Okay, I just thought I'd drop this one in actually, and this is slightly different to some of the other presentations you've seen, because I quite often get asked, so who pays for all of this? How does this work commercially? And a point I've been making, I think, for probably a couple of years on HyNet. When we look at HyNet in terms of risk, I talk about 3 buckets of risk. You've got the technical risk, you've got the planning and consenting risk, and you've got the commercial risk. And actually, I think the technical bucket of risk is not the one which keeps me awake at night. There's nothing in the HyNet system which competent process engineers, geologists, mechanical engineers can't deliver. The planning and consenting, it's time consuming, but there's a good process and it will happen. The challenge is, how does all this glue together from a commercial perspective? And the UK government, Bays, are doing the most phenomenal job in building a framework of business models which allow private sector to invest to make this happen. But all of these need to come together. So I'm not going to dwell on this slide for a huge amount of time, but just briefly, at the heart of this, we have ENI. They are going to form a transport and storage company. They already have done. That will be a regulated asset base. So Ofgem are almost certainly going to be the economic regulator. The technical regulator will be the Oil and Gas Authority. And the economic regulator will set the allowable revenue which ENI are allowed to secure from their customers. Their customers will be the transport and storage system users. So for us, that's our industrial capture plants and our hydrogen plants. Both of them will receive income from a contract for difference counterparty, likely to be the low carbon contract company. That will allow them to fund their operations and pay their transport and storage fees. The hydrogen plant will receive its funding from a hydrogen shipper, and the hydrogen shipper will charge the hydrogen user the energy costs, but they will also recover the distribution and storage costs, which will fund the hydrogen pipeline network, who in turn will be regulated by Ofgem. So hugely complicated. This does underpin all of what we're doing, but as I say, BEIS are moving forward on this very rapidly. They're publishing their business model updates on a regular basis. There are good, strong expert working groups which have been built between industry and government to enable all of this. So if you just go to the last slide. So just to sort of close out on our key messages, so if you just step through all 4 of these, yeah. So we, as HyNet, strongly deliver against government targets, 100% of CCS, 80% of hydrogen. We're displacing almost half of regional natural gas use, and we're taking out 1/4 of all the regional emissions in the Northwest. Next one, please. Operational from 2025. We've talked about where we are on the project and the momentum, but we've got several hundred people working on HyNet now across our supply chain, all pulling together very well. And on the next one, please. Yeah, so one of our key selling points is we're hugely affordable. So we've got very well characterized reservoirs, and that reduces risk and the cost of characterization. We're reutilizing almost all of our infrastructure on the TNS side. That reduces capital costs by up to 50% from new build. We've got very low cost capture from industrial sources, and we've been optimizing our hydrogen production, and we've chosen our technology to make that an affordable low carbon hydrogen solution. And last but not least, it's green growth, and a lot of the other clusters have talked about this as well. One of the things we're proud of is that we've attracted new investment to the region. So Viridor could have chosen any of their fleet to decarbonise, but Runcorn offers them a really good connection into HyNet, so they're bringing investment. We have a couple of new plants who've chosen the region, so Fulcrum, a sustainable aviation fuel plant, and ABSL, a sustainable gaseous transport fuel plant. We're delivering 6,000 jobs during the construction phase, and fundamentally we are partnering with local regional authorities to provide the infrastructure which Liverpool City region, Greater Manchester, Cheshire West all need to deliver their wider net zero targets. So we're very confident that HyNet presents a very compelling investment proposition for UK government. We have, like all the other clusters, been making that very loud and clear over the last few months. And now we all wait with interest what government have to say in the next few weeks and the outcome of cluster sequencing. And I'll leave it there. Thank you very much.
David, thank you for a very clear talk, and must say I'm really taken with the idea of creating the demand, getting that demand pull, and already be running some of those early tests of using hydrogen in process. I think that's a really powerful way of turning things around and getting pull from the industry. So thank you for that. We have 8 minutes now for questions. So I'm going to ask all our panelists to come online here. I'm going to start with a question for Alan and David Richardson. It's about CO2 purity and dryness. Now, Alan, you're going to have to commingle this and run it into a reservoir. David Richardson, you're going to have to get this into a ship somehow. So Alan, your thoughts on who sets or how do you set the standards for purity and dryness to commingle?
I think each of the systems, whether it's the Scottish cluster or any others, will have a standard. The standards of purity will be pretty similar and particularly constraining on water content. So if the CO2 supply does not meet the standard of the system, it won't get entry, and that's about it. I mean, you've got to remember that these transport and storage assets are going to be servicing many different customers. It's very important that they are protected so that they can continue that use, and having that standard enforced is an important part of that.
And is it the job of the storage operator to set that standard?
The storage operator, we're anticipating that will be part of the economic license with Ofgem, is to set that standard up. But I suspect there'll be commonality across the different clusters in that regard, so that there's interchangeability. Right.
Okay, great. Thank you. And David Richardson, any twist on that in terms of putting CO2 in a ship?
No, I think so liquefying CO2 is going to require a certain amount of dryness in any case, and so from our perspective, no issue. I think the challenge that we will have, and that we've identified, is that of course we will have choice over store that we we may contract with ultimately, and therefore if stores have different standards, then we will have to balance our inventory to suit that store such that it meets the standards when it leaves in the vessel. But we see technically there's no issue with it. It's purely something that becomes a manageable exercise. And the key driver around it will be cost. The more effort you put into purifying the CO2 and drying the CO2, the more costly it becomes. So we'd like to keep the cost down, of course. So that will be a factor in our consideration. Thanks, Bill.
Thank you. David Parkin, I'm going to go to you next. There's some concern that blue hydrogen can quickly become gray hydrogen if the CCS isn't in place. Your thinking on how we deal with that? How do we make sure that the blue doesn't become gray, and what we do if storage is delayed in coming available?
Yeah, sure. Look, I mean, it's a really good question, but no one is going to set out to build a unabated blue hydrogen plant, making it grey. The regulators will not permit on that basis. But you're right. Even with the best intentions and the alignment of investment decision making on the hydrogen plant and the CCS side, there is still a risk that for whatever reason the CCS may not be operational or may be delayed. I think the best way of sort of considering that is that CCS will not be sanctioned for construction without a permit from the Oil and Gas Authority. They will look very closely at the risks associated with that infrastructure. So the long-term storage risk, sort of the short-term risks associated with operating that. And particularly with HyNet, we're actually operating 3 storage reservoirs, which helps minimise some of that risk. And there'll be full reliability assessments of the network, and we're certainly looking at sort of 99% plus reliability. So I think the chances of not having a TNS system operational are very low. It is a risk which all parties are going to need to consider, but we are still very confident we will be delivering a low carbon hydrogen system. And we're taking 97% of the carbon out in our process. If you also include the upstream emissions associated with methane production and the E&P and the transportation elements, we're looking at between 85 and 90% emission reduction overall. And we think doing that through blue hydrogen is absolutely the way of decarbonising large sections of heavy industry. But completely concur, it's not risk-free, but the regulatory structures are in place to manage those risks.
Great, thank you, David. Now, we seem to have a matchmaker on the line as well. And noted that David Parkin, you've got a big store, and David Richardson, you've got a big source. Has there ever been the thought of connecting the two with a pipeline?
Shall I take that? So,
Sure.
So of course, South Wales doesn't have a store, and North Wales does have a store theoretically. It's in the mindset. It's not in the deployment plan at the minute, but it's definitely in the mindset. And one of the great aspects of the 2 clusters is that we have a collaborative way of working, but also we have progressive energy as part of the South Wales industrial cluster. So that gives us a good insight into that. It's a challenge. It's a long way. But along the way, there are some regions that are, shall we say, landlocked, that are also looking to decarbonise. So who knows in the future? Maybe there should be. David, did you want to add anything?
Yeah, I mean, I guess the point I would make is, it would be quite a challenge to run a pipeline up Offers Dyke on the border between sort of Wales and England, much as we might like the engineering challenge. I mean, I think if there is going to be a connection, it's more likely to be shipping. It offers more system flexibility. I think the other point I'd make is storage capacity in the Irish Sea is not limited to Liverpool Bay. Liverpool Bay's got about 200 million tonnes of capacity. Morecambe Bay's got about 1 billion tonnes of capacity. So, plenty of opportunity in the wider Irish Sea to be picking up sources from across Western Europe, whether that's Ireland, France, Portugal, Spain, and shipping into a wider sort of Irish Sea development.
All right. Thank you. So I regret we've run out of time. Some very good questions having to be left in the hopper there. I want to thank our speakers, Pierre, who's had to leave early, Alan, David, and David. Excellent presentations. Appreciate the clarity of the answers. And yeah, we look forward to hearing about the progress and certainly about the sequencing. If I could ask everyone on the line to remember to stay tuned. There's some excellent sessions coming up this afternoon, CCUS and power generation, finance and CCS at dispersed sites. It's a full afternoon. It's definitely going to be interesting. However, before I sign off, I'd like to thank the CCSA for their work in making the clusters a reality, to Rachel Mills and her team working tirelessly behind the scenes to make the conference a success, and to all the delegates. So thank you for joining us, and we'll sign off on behalf of all the speakers today.